Hello guys, welcome back to my YouTube channel. So on this video, I'm going to be explaining my end-to-end Formula One project. So this project combines, the work is mainly done on Databricks, but I also combine other tools like Power BI for data visualization and Azure Data Factory to build my pipelines. So on today's video, I just want to explain what I did and how I was able to get my result. I want to start by showing the dashboard. So this is how the Formula One dashboard. I got this inspiration from the BBC website. So if you go to the BBC website under Formula One, you see something similar to this. So here in the first page, I showed the top Formula One drivers in the last decades. I used a scattered plot here. As you can see, it's Lewis Hamilton is here. I also show it for the all-time drivers that raced more than 100 races. The first one is more than 50. Yeah, that is for this page here. And I also show the table here. Then we have uh, another page here like this. This dashboard contains 3 pages. This is the first page, and one like to show you the second page. Now this is the second page, and the the dashboard looks exactly as it is in the BBC website. So if I take you to the BBC website, so this is the BBC website here. So as you can see, this is for 2020 Abu Dhabi Grand Prix race. So you see here it is being switched. There are 3 switch buttons here: race, qualifying, and practice. And you can see in 2020, Max Verstappen took first, then Bottas, then Lewis Hamilton. Then if you come to my own dashboard, you see it's same thing: Max Verstappen, Bottas, Lewis Hamilton. Like, I got the inspiration from the BBC website. I was able to get the data, and I built this dashboard. So I'm going to tell you what I did to be able to get this dashboard. This first page is not there. This first page was entirely my own idea. You won't find the first page in the BBC website. This first page is entirely my idea. I use my previous knowledge of creating dashboards to create the first page. As you can see, it looks so beautiful, and you are able to visualize the data. First thing I would like to do is to kind of explain the solution architecture. So the data is gotten by the EGAS API. Like, if you use EGAS API, you're able to get the data. But me, I was able to get data on one GitHub page. I got all the data from 1950 onto 2020. So that's how I got my data, and I ingested it into my data lake. So I had the architecture I used was the medallion architecture. So either you call it the bronze, silver, or gold, but me, I called mine raw presentation and and transformation container. So I ingested this thing in. I ingested all the data in the raw container, and I did the transformation here, and it went to the presentation container, and I did more further transformation, and it went to the from the raw to the process container, and further transformation to the presentation container. And from here, you can connect it to your dashboard to do your reporting, or yeah, you can connect it to your dashboard to do your reporting, or you can connect directly to Databricks and do your reporting. And the tool I use in moving this data from one container to another is the Azure Data Factory. This is where I created my pipeline. So I'm going to explain this whole architecture in this video, and I hope you follow along. When I was creating this Databricks for this Formula One project, I initially started writing it in a Packet file. So if you can see here, I have a Formula One reporting first view. So this is one I use for my dashboard. So I'll explain that first before I'll explain the other one. So if you open here, you see all my ingested data, the circuit file, the race file, the construction drivers, result, pit stop, lap times, and qualifying. So I want to also categorically state that I have already mounted my container on my Databricks, which I'm not going to go into because I don't want this video to be as long as my previous COVID-19 video. I want this video to be a little bit short. So I've already mounted my container, and yeah, so here I have a widget here. If you can see here, I have a widget. So this widget is just to kind of create a new column that states the source of the data. So, and this configuration I have is for the um, like I invoked a notebook in another notebook, and this notebook kinds of like indicated it kind of indicate that the containers have been mounted. I don't want to explicitly state the code on this notebook, so I had to state it in another notebook to invoke it here. So here, in order to read the file, you have to kind of state the column types. So here you see I've stated the column types here. I read the notebook. This one is a CSV file. I selected the columns I needed, and I renamed the column, and I dropped some column here. I dropped one column, the ingestion date. I dropped it, and I now wrote it into my new container. That is a process container. So I wrote it as a packet file, and I overwrite it. So, and yeah, that is for this file, and the same goes for all this file. You just read it, clean it, process it, and then put it in the next layer, which is the process container. So, and yeah, that is what I did for all these files here. Like if I open the next one, you see here I state the data types. I read the particular CSV file, and here I selected the columns I wanted. This time, as I'm selecting it, I'm renaming it. So you use the call function. You select it, you rename it, and here I also concatenated two I concatenated two columns together here. Yeah, I dropped the ingestion date, and I wrote the data into the packet file. So you see, this is the first thing I did, like to ingest the data into my process container. So once I read the data from the raw container, I processed it, just change the column type, drop some column, rename some column, and I now put it into the process folder. And then after I finished this, so what I did was I now copied the processed data into my SQL database. And how did I do it? I used my Azure Data Factory pipeline. So if I open my data factory here, you can see here my pipelines. I have two pipelines. I have for COVID-19, I have for Formula One, and I've already explained my COVID-19. You can go to my YouTube channel. You'll see I did the COVID-19 video. It's an end-to-end project, just like this one too. So if you open this here, you'll see where I kind of copied everything to my SQL database. Like if I open this PL SQL circuit, like you see it here. So So first of all, you have to, for you to copy something, you have to create a source data source. First of all, you have to create a link service. I've already created the link service. Then you now create a source data set, which I created, as you can see here. I created a source data set. It is a packet file, and because it's a packet file, I use the wildcard file path, as you can see here, and you now create the sync data set. And the sync data set this time is going to be a, SQL database sync, which are created here, as you can see here. And I dropped the table so that if you refresh it, it will like kind of first of all drop the table that is there and put new data that put new data. and yeah, so I was able to copy that process file from my process container into my SQL database. And I did the same thing for other files. As you can see here, I did for constructor, driver, lifetimes, qualifying, race, and result. So if I can show my SQL database, for example, here, so this is my SQL database, and you can see them here. For example, if I open, if I op if I kind of select this one, so as you can see here, you can see the data here. Because the kind of architecture I used was to first of all copy the data to the SQL database before I now connected it to my Power BI dashboard. And here, after I copied everything here, then I now connected it to my Power BI dashboard. One moment. So I connected it to my Power BI dashboard and I imported my data here, and which is what we have here, which is what I have here. And once I got the data here, then I did my data modeling. As you can see here, I did my data modeling and I connected all my tables together, connected the facts to the dimension together. Then I started building my report. So like this is just like a short like overview of what I did from Databricks. I got my data in the raw container. I processed the data by kind of uh, giving them a column uh, type. I cleaned the data, dropped dropped the columns I don't want, and I saved it in the process container as a packet file. I got the data as a CSV file. Some of them are as JSON file. I save it as packet file. Then after saving it as packet file, I now use the Azure Data Factory to copy this packet file into my SQL database. And after copying it into my SQL database, I now imported those tables on the SQL database. I imported those tables into my Power BI and I built this dashboard you are seeing here. So this was the first thing I did. But later, I decided to work with a much more better format, which is the Delta format. This one was the packet. I decided to work with Delta because Delta give us more capabilities than this packet file. Like with the Delta files, you can do something like ACID transaction, time travel, versioning the data. You can also delete the data. You can also go back to a previous version. So that was a better form to work with. So in this particular one, I just This particular one here, I just did it with packet file for me to be able to visualize the data and build the dashboard on Power BI. But later, because in an organization where you receive 3 GB of data, you cannot be overriding the data all the time. It is going to be very slow. You are going to spend a lot of money processing the data. So it is best you use the Delta format so that you can be able to you can be able to do incremental load. So now here in this particular ingestion here, I I use the Delta format. So one thing I forgot to mention is that from file 1 to file 4 is their dimension tables. So in dimension table, dimensions do not always change. They are always constant. So you can override the data all the time. But fact table are always changing, and it is best for you to do incremental loads for them. So I'm going to just pick one or two uh, dimension to explain, and I'll pick one or two facts to explain before I'll now move to the next thing. So let me just pick this races file. This is a dimension file. So for this one, I had two widgets. I had the date widget and the data sort widget. So why do I have the date widget? So when receiving this data in my container, I receive it in the form of date. So as you can see, on the 21st of March 2021, I received this cutoff file that contains all the historical data here. Then I now received another one on the 28th, and I received another one on the 18th. So because of that, we need to have a a a time widget to be able to read the data per date, and this is what I did here. So this is just putting the data types, and if you can see in the read statement, I have this widget here. You understand? So this particular v file date reference any date you put here. So it will just go to the container and search for the data that falls under this date. That's what it does here. So I read the data, and yeah, I did some column selection and column renaming here, and yeah, I overwrite the data and I partition it by race here. So if you are partitioning data, it's going to run better and it's going to save faster. So and if you see here, I didn't use incremental load. I didn't do incremental load here because it is a fact, it is a dimension table. So there's no point because you receive the data, you receive same data all the time. So there's nothing increasing and you don't need incremental load here. And if you notice again, I saved the data as table. So that means that instead of reading it uh, reading it with that long long link, you can usually read it as table like how you read your normal SQL statement. So you can just read it like an SQL statement to get your data. So this is one of the fact table. Let me show another fact table here. Let me show this construction file. So as you can see, it has two widgets here, the date and the data source. And yeah, I put the data types, I read the data. As you can see, I'm indicating the particular file date to know which particular folder it is reading from. And here, and I selected the data and renamed it, and and saved it. And I forgot to mention in the previous one that I'm saving it as Delta, because I told you the Delta format is better than the packet format, because this one gives us more capability to kind of go back to the data, do ACID transaction, time travel, delete some data, you understand? And that is the importance of the Delta file. Then after that, I would like to show some fact table. So let me open this results file. So this results file is a fact. It's a fact table. So here you can see it even has a lot of columns here. So I started the data types here and I read the data. I selected and renamed the data, and now the incremental load. So there are various ways of doing incremental load, and as you can see here, I have the incremental load first solution, I have the second solution, then I I now have for the delta files. So this first and second solution was the one for the packet file. But right now I moved to delta files, so I have to remove it. So for the delta files, what you see here is a function. So I called a function, but I'm calling this function because at the back end I have a function that I have in another notebook. So I invoked it into this notebook. So this is what I want to take you. So this is a function file. So in the function file, this is here the function, and this thing is publicly available in the documentation. I just copied it and did some um, changes here. So what this thing checks is that it checks to see if the table is available. Mind you, in the when I was saving the 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 my when I was saving the data, I saved it in form of a table. So obviously you already have a database and a table name. So it will check if the database and the column exist. If it doesn't if it doesn't exist, it kind of merge all your incoming columns. But if it exists, it will first of all check which one is not there, and it will now append it. So that is what this whole function is all about. So instead of always overriding the data, because if you have 3 GB of data, overriding the data, it's not a good cost management approach. You are going to waste a lot of time, you are going to spend a lot of money. So this incremental load uh, approach is the best. So instead of overriding it, it just goes there, check the particular data that is not there based on the partition column, because you have to indicate the partition column, to check based on the partition column and check what particular data is not there. Then it will append the data that are not there. But if the table is empty, it will just upload all the data all together. So I put this in a function, and the function takes in an input data frame, a, a database name, a table name, a folder path where it is going to save it, a merge condition, and a partition column. And that is what you have. That's what you have here. So this is the input data frame. This is the database name. This is the race result. This is the process folder path where it is going to save it. And this is the merge condition. And we merge it on result ID and on race ID. And of course, the partition column is the race ID. So this is the incremental load I implemented, and it worked like beautifully. Then um, then I want to also show one more example of the fact table, because I said I want to make this video short. I don't want to make it. I just want to explain what I did in my Formula One project. So this is the pit stop file. This is also a fact file, a fact table. So here I already explained this. So I put the data type, I read the data, and as you can see here in this option, this is a multi-line JSON file. So for you to be able to read it properly, you have to explicitly state this multi-line is equals to true here. So I read it here. I I renamed the data here and also did the same incremental load logic here. So after all those things, I saved all my data successfully into my process container. As you can see here, I have all the files here into my process container. And to show you that this is a Delta file, if you open this result here, you see here, this is the data log. So you see here the JSON file, and everything is saved in form of partition. Race ID, for example, here. So you see here, it's partitioned the data up to 99 races here. Yeah, so that was what I did. And after getting my data into my process container, now we want to start the transformation. And I have my transformation file here. So I have my race results. So here also I have to put the file date because I want to also uh, uh, incrementally save this particular data because I do not want to override it. So if you remember when I was cleaning it in before saving in the process container, I make sure that each column or each row has the file date in it. Let me show it here. So if you see here, I added I added a column here as file date. I added this file date. So that means that if you read this data now, you will see a file date column so that I can be able to use it in the next transformation to incrementally load the data. So you see here, I load this time here, I'm loading the data as a form of Delta because it's now a Delta file. So I selected the data here, and so here, um, so this is for the circuit file. Then I loaded the driver file here too, selecting it, transforming it. I loaded the constructor file, I loaded the race file, I loaded the result file. So this result file is a fact. This is a facts table, and that is why I also included the file date here. Then I did my joins, inner join, I joined the race, the circuit file, the circuit table with the race table. I joined it by the circuit ID and all this. I also joined it with results. I joined it with the driver. I joined with constructor, and yeah, and at the end of the day, I I dropped this constructor ID, circuit ID, result ID, driver ID because I don't need it. And here I saved it incrementally. Why? Because I already have a file date. So this is why uh, what I do is that I call the date and it will save it by date instead of overriding the whole thing. So, and the merge condition is the driver ID, uh, the race ID, and the race date. And for this driver standing, first of all, I have to filter it by the file date in order to incrementally load the data. So now what I did here is that I kind of uh, found the distinct race here and put it in a list. And here I created a list here and I appended this particular race results list, like the distinct race here in the list, so that I can be able to use it to filter the year when I'm incrementally loading the data, because the data is from 1950 onto up to 2021, and I do not want to always loading the entire data. So I want to be loading it by per year, so that it will save cost, it will save time, and it is more efficient that way. So as you can see here, when loading the race result data frame, I filter the race here in this race here list. So what I did here was to collect the distinct race here, append it to this list, and then I kind of filter the race here from this. So that means that any file data pass into this place, it is going to filter only the race here. So for example, if you pass in, so example here, I pass in the file date of 18th of April 2021. So what it will do here now, it will only filter for 2021 data and leave the rest. So this will help us to incrementally add the data. And here for these drivers that are standing are grouped by race here, driver name, and driver nationality. The aggregation, I sum it by points, I alias it as total points, and I am only interested in those drivers that finished first, because the data is from 1950 up to 2021. So I'm only interested per year on, and per race year. I'm only interested in drivers that finished first. So that is what I did here. And then in order to rank them, I use this window function. Of course, I partition by race here, I order by total points and by wins. And yeah, and I got the ranking. And then here I perform the called the incremental load function that I've showed in my previous notebook. And this time I I I the merge condition is by uh, is is by driver name, because the columns which we're choosing here are driver name and race here. So the merge condition is driver name and race here, and the partition column is race here, and here I now match everything. Analysis for constructor standards. For the constructor standards is very similar to the driver standing here. So I also codified it here. I found just similar to the driver standards. I found the distinct uh, uh, race here, and I put it in a list so that I'll be able to filter it as I did here. I filter it. And here for the constructors standing, we're only interested in the team ranking, not this time, not the driver ranking. So that's why you have only the race here and the team here. I sum the points. I was only interested in those teams that finished first. And yeah, I did this, I call this window function to get the ranking. And I call this incremental load function here. I joined it. The merge condition is by on team and race here, and the partition column is race here. And here, this is the database name, and this is the table name. And yeah, it worked. And this is the ranking for 2020, and the result is as expected. So now, after all this analysis, the next thing you will do is to like create a pipeline. And I've showed in previously how I created a, the pipeline for my dashboard. But right now, the notebooks right now have are being parameterized. So they have these widgets. And for you to be able to load the data, you have to create a pipeline in such a way that you are able to pull that file data. So if you come to Data Factory here, so this I created one pipeline. This ingest circuit. Um, yeah, so this particular uh, ingest circuit file, for example, it is actually parameterized. So uh, it is actually parameterized. So if you check here, I've already created the link service, and if you remember, the notebook has two parameters. It has the file, the data source, and it has the file date. So if you see the base parameter here has is two, is the data source, and the file date has been created. And for you to get that into that place, you have to come here, you click out, you come to variables. I created a data source, and I had coded it because the data is coming from a gas API. And for the parameters, you you put this window, I just name it window end date, but you don't parameterize it, because when we click on debug, it will kind of open a panel for us to input the particular date we wanted, and then you now run the code and you get it. So that is how this thing is created. So you can add more parameters if you have more parameters on your notebook. Like after creating this data source, if you click on this place, it will show you different parameters you have. Like you see here, the v data source that we created here. On the values, this is the v data source. So we called it here. We called that variables here. And for the file date is this parameter we created, and we the file, it is a date, and we kind of change it into a date function. So first of all, we call the date function here, and then the parameter, and we now keep the we now put the format of the date I wanted, because this is how it is in the file. This is how the file, this is the format the file comes in. So I just put it here and I clicked OK. So now if you click on debug here, it will ask you for file date. Then you now put the date you want, maybe 21st, 3rd, for example. Then you now click OK, and it will run the pipeline. So if I test run this pipeline right now, so first of all, what it will do is that it will first of all go and spin up the cluster, because this is a Databricks activity. It is usually attached to a cluster. And so when creating the link service, you'll be asked for a cluster. So this is the one I'm using here. So it's usually been attached to a cluster here. So they will ask you to choose a cluster. So when you put everything, your subscription and everything, and you come to existing cluster, you see the clusters you have. So they will ask you to pick one, and you pick one and create it. Because if you don't have an existing cluster, you can create a job cluster, and the difference is that after the job has been run, the cluster the job cluster is going to terminate on its own. But an existing cluster, it won't terminate, except if you have a time limit when the cluster will be on, if there is no activity on it. So let's check our job run. So this is it. So it's still running. So we have to check if the cluster is So you see here, it say it is waiting for the Databricks cluster to be ready. Let me go here and see whether the, so as you can see here, it has already spinned the cluster here. So the cluster has to be ready before the pipeline can run. You understand? So and yeah, and that is how I created this thing. So this pipeline, what it does is that it just first of all, according to the notebook, it gets the data from the source, perform the transformation, and load it into the process container. You understand? And the initial pipeline I still have pipeline that there is copy activity. For example, this one right now, it copies the lifetime data into uh into the it copies the lap time data into our SQL, Azure SQL database. If you see the sync, it is a database here, and I also truncate truncated the data so that it can be adding new data so that we will not have duplicate. So yeah, so this is just like a rough end-to-end data analytics project. I know I didn't really dive in into this project because if I want to start explaining everything, this video is going to be a lot. I did a lot of explanation in my COVID-19 um, project, and it was 1 hour 40 minutes. I don't want this video to be long. This is not actually to teach. I'm just here to kind of explain what I did to get my result, what I did to get to be able to get the dashboard that I showed in the beginning. And if you want me to go in-depth explanation, please let me know either in Data Factory or to explain my Databricks code or to explain my DevOps because I have to also publish my code to Azure DevOps. So I'm open to explaining all those concepts. Let me see if the cluster is on. This is going to take a long time, and I'll come back to it when it is done. You can see the cluster is already running right now, so I think the pipeline should be running. So if you come to this monitor, you click on it. So you can click on refresh to see the progress. So if you want to see what is going on, if you click here, it will like bring a link for you. So you click that link, and you can able to track the progress here from the notebook too. So as you can see, it has already run this thing. So it says it's running the notebook here now. It's still running. I think it should be done any moment from now. So if you want to see the progress, you understand, this is how you see it. So I think it's done. So if you go here and refresh now, it will tell you succeeded or completed. So you see it's already success here. It's supposed to show, like you see it ticks green here. That means the pipeline has run successfully, but I'm supposed to see the status. Okay, see status here succeeded. Yeah, so you see everything has run successfully. All status here you see succeeded. It was in progress before, but it succeeded. And I think, wait a moment. Um, yeah, so you see here, it succeeded like 6 minutes 32 seconds ago. It succeeded. The pipeline succeeded, like it ran successfully without any form of errors. Okay, yeah, see what I was looking for here. So succeeded, and if you look at this, you can look at your notebook. So you see, run output success. So everything ran perfectly as we expected. So this will be the end of this video. As I said, I just wanted to kind of briefly explain the process. And here right now, what I can do here is kind of have multiple notebooks for all the injection file and all the transformation file and run them. So, but I did not really need all those. I just needed this them here. As you can see here, I've already ingested it into my Azure database. I've already ingested them here, so I don't need to do it again. Even the driver standings, the construction standings, and the race result, I've already ingested them, and I imported them um, into my Power BI, and I analyzed the data.